ControlUp automation, automatic remediation. Touching on the previous series, ControlUp automation can gather additional data by responding to events faster than a human is capable. But what about remediation? If we have gathered enough data and are awaiting analysis, but we are still experiencing outages, we need to minimize these outages as much as possible. To do this, we can look at where ControlUp automation can help us reduce minimum time experienced by a Citrix database outage. To start, we are going to be looking at the process that occurs when a Citrix database outage is experienced. In this diagram, we can see the components of a functioning Citrix service. The principal broker is communicating with the database, the VDA has registered with the principal broker, and the user can access their applications. When the site database goes down, the principal broker instructs the secondary broker to start and makes it handle all connections. During the change, the VDAs are unregistered and the users cannot access their applications. The VDAs wait for their heartbeat interval before communicating back to the broker. Upon sending the heartbeat signal, the broker will request registration. The VDAs will register with the secondary broker, and users can now begin to access their applications. This process has timers that cause delays. The first timer is a 90-second delay from when the principal broker notices the database failure to when the secondary broker activates. The next timer is the heartbeat interval for your VDAs. By default, this timer is 10 minutes with a check-in at half that time, 5 minutes. Using ControlUp automation, we can reduce the database inaccessible delay from 90 seconds to around 8. To start, let's create our script action. I've created a script action called configure LHC mode. It will be assigned to a computer record and run under the target computer execution context, with the security context being local system. My script will accept a single parameter, a switch named force LHC mode. This will set the registry key to force activate the localhost cache. Finally, under arguments, I created a prompt for parameter input and set the default as force LHC mode. When ControlUp automation runs, it will pass to the script whatever value is specified in the default. I am going to configure the trigger. The record type is computer, with the filter being XD database connected being 0, which is equal to database down. I'll include my organization as my scope to capture all delivery controllers I might have. I will add 2 actions to this trigger. The first is the script action to enable the localhost cache. In this action, I will also choose to receive an email with a custom email template. Next, I'll attach another action, this one to email the alert, which will also activate the run in action email template, and we finish our trigger. What does this look like in action? On my left, I will demonstrate the localhost cache activation, and on the right, I'll have ControlUp automation activate the localhost cache as soon as the database failure is detected. I have a script that is continuously simulating a user's logon process through Storefront with the time in milliseconds for how long the process took. We are now experiencing a database outage, and we can see the connection has been lost with the request timing out after 2.2 seconds. The principal broker waits about 20 seconds before it generates an event that it is unable to contact the database. This appears as error 1201 with the message, the connection between the Citrix Broker service and the database has been lost. ControlUp triggers on this event and turns on the localhost cache. The automation is picked up by the event logs with the details of the action. With the localhost cache now enabled, the handover between the principal broker and the activation of the secondary broker takes place. This takes several seconds. The principal broker notifies that it has stopped its services as they are now handled by the secondary broker. We can see the secondary broker start to handle requests as the requests now only take 200 or so milliseconds. At this stage, we are at the mercy of the VDA having its heartbeat interval trigger so it can register with the secondary broker and begin to service applications. More servers or reducing the heartbeat interval would bring the services up quicker. For all intents and purposes, the failover is complete. Approaching the 2-minute mark, the secondary broker now activates for the standard localhost cache process. Again, VDA registration is what we are waiting for now, but the failover to the secondary broker is now complete. Want to learn more? Visit www.controlup.com.